can start today. I think you all got the mail that today is more going to be like an exercise class, and I actually don't know how long it's going to be, but let's see how many questions you have. So today we're going to, basically it's your chance to ask everything you want on what we have done during the semester. If you have anything that it's not clear, ask, because that's basically the last exercise class. So any questions on the exercises, on the examples you have seen in the class and so on. But before coming to that, we're just one slide that might concern some of you, and these are informations on the exam. So for the moment, everything we know that it could take place the 4th of February. I think the final date will be final, I don't know exactly when, but I guess in 1 month or so, so always check the calendar for updates. The exam will be 3 hours, and we're going to have a part with multiple choice that you will do on paper and some programming. And for the programming exercises, that's actually something we advise you to do in the next days, to go downtown in the main building of ETH and check how does the Linux system look like. So that's this. I mean, if you go downtown, you go in the I think you know better than us, the computer rooms there. You have a dual boot. You can boot in with Linux. And that's basically the system you will get for the exam. All the tools you have there, all the text editors you have there, that's what you can use during the exam. Maybe not the browser, but other stuff. I mean, the basic utilities you can use. So maybe you will not get Xcode or the Visual Studio from Microsoft, so it's worth giving a try on running some code on these machines. And programming exercises also means it's very likely you will be asked to do something with the tools we used in the lecture for the moment. So just to mention something, Makefile, CMake, Git. Not just learn C++, but also think of what we have used for the exercises. So that's all part of the exam. What you can bring to the exam. So if you have something printed, everything you want. But in digital format, basically nothing. The computer is what you get. On every, well, you don't really have your own folder during the exam, but on every machine you will find an offline version of the CPP reference website. I don't know if you already use it or not as a documentation for C++. Just be aware, since it's an offline version, it's a bit limited. There is no search function, but I guess it could be useful in case you have to, I mean, when you have to program C++ anyway. Any questions on the exam that I might be able to answer now? Yes? Maybe not the slides, but this stuff we might copy it on the website in the end. Something else? Okay. Well, anyway, next slide is questions. So this was the main point of today's lecture, exercise class, how you want to call it. Do you have questions on the exercise, on what we have done? Questions on C++, anything? If you just want to look at one of the example solutions with us, just mention, I can open it and we can explain it again. Yes?
I have a question, where to link the libraries, because I noticed it makes a difference where in the command line you link the library.
Yes. So how you compile a program, it's fine for everyone. That you first create an object file. That's, if you want to do that as a manual step, that's the -C option when you're in the compiler, and then you use the linker. When you use the linker, you have, so now let's see if I remember exactly the sequence. So it doesn't, it matters the way you order the, so you have to put minus L, something like C++, and then here you have to put, you put the, let's say your object files, main.o, then you might have your random.o, and then you might have a sequence of libraries. So you might have the library that we called integrate. Then you might have BLAS that you have seen in the last exercises. Then you put minus O and the name of the object file. Let's call it program, the object file. I mean the final file. Now, here the order of these libraries matters, and namely the from this library, the final object will only include the functions that are called from the previous ones. So you should put at the end the let's say the lowest level library that you have. Now let me check for confirmation on that corner, but it's the last one. It's thanks.
I mean, the main point is that the symbols that are not defined in one object file or one library need to be found in a library that comes afterwards in the link time, right?
Yes, and link it from left to right, huh?
Exactly, yes.
Okay.
So it may even be necessary to repeat
some
one
libraries,
library. Yes.
And if I'm not mistaken, but that's just more advanced if you want. Some compilers, some linkers have the option to do something like a cycle around a few libraries. Or, but that's just, anyway, just, you can repeat libraries, it's not a problem. You can put here another minus L integrate if you want. Yeah, that's important. And that's it. So the last one, you have to find symbols in the one coming afterwards, going from left to right. Something else? Yes? It's not really needed because if you go on the website, there is an offline link, and that's the one we will download. So you can just try it out yourself. I can just quickly show you. For sure, we can also publish it, but in the end, so on the bottom of the website, once it's loaded, you have offline version here. And it will be one of, I think one of these. Yes?
What kind of editors can you use?
The best is just go and have a look. But you might have, I don't know if you, I mean, what are you familiar with? You might have gedit, Vim, if you use something in command line. I think if, as a more advanced editor, you might, if I'm not mistaken, you have code block. What do you use usually? Huh? Might be there. Just go and have a look. Something else, another exercise? Yes?
You have to know the canon or the particular.
I mean, let's say it's not as is not a biological exam. Uh, in case there is something you have to know about the PENA model, we might give you the formulas that you have to implement. And if you need some part of the PENA model, we might just give you an header file or something like that. But it might be useful to know which techniques you use, why we used such an interface or such a container. I think you don't have to know the fishing that allows the population to survive or not. Or something else? So it's clear for everyone. We could take the exam now. Yes? That's the first time we do that. Yeah, you are the test. It's the first time that the exam changed, and that's why we might go through the old questions we use for the oral exam now, if you want. So we used to have a list of questions to ask in the oral exam, and now we just put them together here. And if you like, we can just go through and see if you can answer all of them. It's a check for you in the end. So let's start from the hardware lecture. How much do you remember? So I show you a question and some of you is going to answer, or do you think we will find enough volunteers, or we have to go in a row, we pick everyone? Let's see if the first question works, otherwise we go in a row. So, who wants to answer this one? Wasn't that the first lecture? Was the quiz, or? Yes?
I think it means if it's written from left to right or right to left.
Wait. What?
When the root integer is small, so the 1 or 0 is the right or the left.
Do everyone agree? Next to you?
So I think if you have multiple byte types, it's if the first byte is actually the last part of the actual 0-1 representation, or if it's the first part. So if say you have 1 0 0 0, and then at the end 1 again, if you have a big endian, you would have the first bit byte starts with 1, and the last, it's actually exactly what you think. And if you have a little endian, it's first 0 0 0 1, and then the next byte is 1 0 0 0.
Do you want to sketch maybe at the blackboard just to explain it better? It's just a bit confusing.
So just to make it...
Just write 1.
Yeah. So, of course, you have 8 times 0, and then you have 7 times 0 and 1, and now a big endian.
So that's if you have how many bits?
So you have 2 bytes.
2 bytes. That's an example of an integer with 16 bits.
Yes, exactly. And so the big endian would just be this way, and the little endian would do it the other way around. So 1 0 0 0. So the last bit is what starts.
So almost right,
Okay.
but
Is it like this? No.
yes.
So the first 8 are actually this.
So endianness is only about bytes and not bits.
Yes. So little endian just takes the last
last byte first.
Little,
the last, if you
Jan.
think about it,
Okay.
the big endian takes the biggest byte first.
Yes. Okay, so be careful, it's about the bytes and not the bits. Because actually, the word that the computer is, really the chip stores, it's really the word, the 8 bits. The single bit, I'm pretty sure, doesn't really exist on the computer. It's just the word exists, which is 8 bytes. And do you know what's the floating point? What's the representation of floating point numbers? What's, for example, one quantity that we look at for floating point numbers? First exercise. So what's the machine epsilon? Do you remember? Yes?
Well, there's a fixed number of bits that are reserved to represent the precision. So the numbers representing the floating point number, and then there's also a basis and an exponent. So, for example, 1 is represented as 1.0000 times 2 with the exponent of 0. And so it's the floating point number is separated into the representation digits and a basis, not a basis because the computer is always 2, and the exponent of that basis.
Yes. For floating point numbers, the standard is to use 1 bit for the sign, then a few bits for the mantissa, which is actually, so let's sketch it. We have 1 bit for the sign. We have a few bits for the mantissa, and then a few bits for the exponents. And the mantissa, it's the part, so every time you write the floating point numbers, let's say you want to write, now I'm already writing the number in basis of 2. I want to write something like that. First things, this number is transformed in the form having 1 in front, and then comma, and all the other digits. And then here we have times, for example, times 2 to the power of 2, if I'm not mistaken. 3, actually, oh? Well, it's a bit misleading with using mixing representation of base 10 and base 2. Anyway, the important part is that that's what you store in the mantissa. You leave out the 1, and you only store the part after. So you leave the 1 in front, and after the comma, you write this part in the mantissa. Then just look in the slides, you have the better definition. Huh? 2 to the 2? Yeah, thanks. And what's the machine epsilon? Yes? Yes. Okay, let's move on. Next question. We started with the tricky section. Yes?
When computing something in the processor, it's composed of few phases. So there's first the data has to be loaded, and then it has to be processed, and then to be written again into memory. And pipelining means that the processor will do some of these steps simultaneously, and not reading the first and processing and writing, and then take the second unit of data and process it, but do it simultaneously.
So
So it's not only about really the data, but I mean the whole instruction requires data, requires instruction. So instead of executing one instruction at a time, since the one execution requires more steps, it can overlap some of the steps needs to execute an instruction. So what's Moore's law now? Come on, that's easier. And someone else, please. Someone on this side? Yes?
Number of transistors on a chip doubles every 2.3 years.
Fine. Does it only hold for transistors?
Peak performance.
As well, yes. Is it also the case for frequency? Was it ever like that? Tricky question. So for a few years, the performance of computers was only improved by increasing the frequency. So there was a basically one-to-one match in increasing the frequency, and the peak performance was also doubling. But nowadays, the frequency is almost constant, if not decreasing, and we get always better and better chips anyway. Next one. That's important. Yes?
First is the hard disk, which is very big but also very slow. And then there comes the random access memory, which is also quite big, normally about maybe gigabyte size. But it's also slow compared to the caches, and there's usually L3, L2, and L1, which will become faster but also more expensive, so the size decreases. And yeah.
That's fine, yes. What's virtual memory? Yes?
If you run out of memory, you can create superficial memory on the hard disk. You can write parts of your actual memory onto the hard disk.
And it's something that you do inside your program?
No, it's mostly done by the kernel of your
Yeah.
operating system.
It's
And you have almost indefinite amount because hard disks are cheap, but it's very slow.
and what's not good about that?
Slow.
Really, really slow. You could try to run the exercise we use to measure the cache and try to put in a big vector and to see if you manage to use the virtual memory in the end. Let's see if you manage to measure that within a day. Okay, now let's move to a new topic. Compiler. What is a machine language? Many people would fail the oral exam. Oh, now we really start going in a row so that everyone has a chance to answer something. Where should we start? There? It's something that for your machine and you should come with the other laptop, Ilya. Is it common to every computer? I mean, is it the same for every computer?
I don't think so. But it is also, I think, operating system dependencies.
Basically, it depends very much on the architecture and whatever you're running there. So it's really specific to your machine in the end, or a class of machines. Next, let's go up. Huh? It's not operating system.
I mean, it's the thing that your CPU interprets, and it doesn't know in principle what operating system it's running it, does it?
Next one, let's go up. I mean, the two of you, I don't know who was.
I have no idea. Compiler translates what you have written in your code to machine language somehow. So I have no idea.
Yes, that's, I mean, more or less what it does, but does it translate directly C++ into binary form? So what's, for example, an additional step? Yes, assembly is a machine very close to the machine language, and it comes straight before the binary format. Is there something before? Someone would like to help? No, not you. Exactly. Other files are not there, and they have to be included. So which part is it? Is it the linker? Huh? Sorry? So that's including other files and executing basically everything which comes with the hash in front. That's the preprocessor. For example, when you have if if not def, define something, these are instructions for the preprocessor. Then you get a huge C++ file with all the files, all the headers included, and that's then compiled into an assembly code. And afterwards, you go from assembler to binary. You create your object file. And the last step that we were discussing before is the linker. You put together many object files. Yes? Have you tried to open it with a text file? It's a binary format, yes. I mean, .o could be everything. It's not really, let's say, common practice. .o, it's for the output when you do compiler minus C, with the minus C option, which is a binary format. But in the exam, I can give you a file which is .o, and it's not binary, so. Okay, let's go up. What's a version control system used for? Oh, forget it, I'm going to look at all the possible versions you had in exam and just look at the last one. So, yes, but what about collaboration? I mean, for the moment, in the exercises, we only use it, you're right, to keep track of all the changes, but yes? So what's yes, but that's this you can still do alone, right? Yes, so it's easy with the version control system, it's easy to manage small changes and merge small changes to independent part of the files. Then if you're lucky, it's without conflict, so it's going quite straight. Do you know some version control system? Just mention some. More than one, please. Yes? What's the difference between them? let's say, the main difference. For sure, the language, it's different and everything. In where? Subversion, yes. When you commit, you need to have the global repository with you. I mean, yeah, you have to have there the global repository. Could be local, could be online, but it's always going to the main repository. So the main idea is that SVN, it's a centralized repository. There is one for all the contributors. Whereas in Git, you can have a full version of the repository on your local machine. You can commit without being online, and then only when you push, you actually push the changes to the centralized repository. Yes, a question?
I have another question about the exam when it comes to version control. So when you develop a project, whenever you commit, you have to, I don't know, pass all the unit tests, add comments, make sure it compiles, make sure it gives the right results, and write huge commit messages. How is this handled in the exam? How often do you want it to commit? How it's just whatever you do is all right?
I mean, would say in case there is really something we want from you, using a version control system, we will try to be the most clear as possible. But let's say you just want to use Git to keep track of what you're doing in the exam, like you have something working and you want just to keep it, to save it, just to commit to have a safe version that you can restore in case something is going wrong. There you don't really care if all the commits compile. It's always a good idea is to have a reasonable commit message. It doesn't have to be huge, but a reasonable sentence, not just like blah blah or space or whatever. Yes, but let's say, for sure for the exam, we don't really, we're not going to check if every revision you have there makes sense. First of all, it's going to be, if you use it, a tool for you. So it's up to you to see how much you want to use it. And we might want you to use it for some exercises, and there we will check if you did what we asked for. So next question, what is a makefile? Up there? Yes, it only works when you compile. You can only use it to compile programs.
No, you can also set
But you would use it only to compile programs in the end. In the example, we've seen, for example, that you can. Yes, so the idea is that you can create targets in the makefile. Sorry? Yes, and have dependencies, and make will just check if there is a new version of the dependencies, and in case it will run the program. It will run the line of code it has to run. So it can be used to generate a figure, to compile a program, which is what we use it the most, but don't be scared if in the exam we ask you to compute the mean of something, I don't know, of a few numbers. It's still a makefile. So next to you, what's a build system?
I would say it's a system that builds makefiles.
Yes. Usually it's an helper system to create makefiles or something that can be used in the end to build. For example, CMake that we have used can also create a building system which is not based on make files. Can, for example, create projects for some IDE, for example, for Xcode, for Visual Studio, and so on. But yes, it's just an helper that can create a building system. I mean, make files or something else that helps you build in the program. Next section, programming. So that's long, so maybe we can just pick a few people answering this question. Modular, generic, and object-oriented programming. Definitions. Let's start from up there. Modular programming. Yeah, it's really about definitions here, and I actually don't know if we actually wrote them explicitly in any slides for the moment. So let's ask Ilya if he knows. So let's say modular programming, it's as soon as you start using functions, you can call it modular programming. You have modules, functions, that you can easily maybe exchange some line of code and will in the end affect many parts of the code, for example. Just that you can group some common line of codes. Generic programming. I think you heard this word very, very often in the last lectures, the last few weeks. Yes?
This is all that has to have template syntax. So we program, we write a function, and it works for many types. It can apply in many situations with different types. And so it's generic.
Yes.
Write a generic mean function with template, and then it works for many types.
It's not only templates, right?
Well, I would say that templates are
The most.
the implementation tool in C++ to do generic programming. I mean, in a different language, you could call it differently, I think.
But
Java
you could
calls
achieve
it differently.
something with virtual functions as well, or? You could have generic types. You can achieve generic programming
So
both
you
with
would say generic programming is saying the same as polymorphism? Or?
You write, if I have different types that derive from the same base, I can write a unique square function because they have the same interface, which is given by the base class. And then I write only one square function. I think it's...
That's more object-oriented than generic.
So do we have an answer to this question?
Templates.
So yes, I think including templates and virtual function, it's more like polymorphism. But even in generic, I'm still not sure. Anyway, object-oriented. Yes.
I think that it's mainly about data encapsulation, because you will not work with the typical types like ints or doubles, but you will create classes, and then and the classes those are called objects, which don't only hold data but also methods to work on that data, and they are separated from other classes, so that yes, to protect the data from other methods that don't need to mess around with it. And yeah.
Yes, I mean, for me, it's
And it's also
enough.
about code have to copy everything.
That's for sure. I mean, code reusability is already part of the modular programming. Yes, I don't have anything to add. You?
Yeah, one could say that with object orientation there's a shift of the programming paradigm that, let's say, before you had functions working on data and the data was shifted around between the functions, and now you have you structure your code as communicating objects, and the objects themselves know how to handle them via their methods. Yeah, there's a lot of ways to view and approach these topics. There's not the one right answer.
So as I said, these are example questions for an oral exam. And in an oral exam, you can always discuss about the answer. There is not really that's the answer, and it has to be written like that.
But if you feel comfortable with the questions and think you could say something about that, that's a good sign also for the written exam, I think.
Yes. Yes.
How would it be with a multiple choice question and with one correct answer? Are we charge minus points?
We still don't know. What do you like more? Yes? No. Not all of them. Some of them, yes. For example, what's the definition of the machine epsilon? We give you 5 definitions. You have to pick the right one. Then you have to find the right page. What are classes and what can they use for? I think we already said. What are templates? Should we repeat it again? I think it's fine, huh? What are traits? That's still a new topic. Let's go down there. Yes, some of you there behind. Traits.
I'm not too sure.
What did you use the traits for? No, not you, someone else. You answered too much. Anyone? Yeah, last possibility. Not really. You can specialize templates for. You can specialize a templated function to do many things according to the type, and that's not a trait. Let's say you can specialize a function for doubles and for integer, but that's not a trait. A trait, it's a function that it's computing with types. Is there a shorter definition?
I would add a meta in front of the function.
Okay, it's a meta function, yes.
It's something executed at compile time.
Yeah, that's important. Traits are executed at compile time. And let's see if there is a question here. We can... let me just check. Okay, let's go on like that. Then we have an additional question to that. What does inheritance mean? We already mentioned that. Someone can quickly repeat the definition? Yes? No one. Yes?
There's more software design where you can inherit a class. You
Yes.
have a base class and then you inherit a class.
And what happens when you inherit a class? You
Well, you inherit all the methods and other things.
yes, you inherit the methods, the properties, everything that was in the base class, and well, all the public part, let's say, or the protected part.
You inherit everything.
Everything, but you cannot call it.
So what's the point then? You get exactly the same thing as the class you inherited from? Or?
No, well, you can specialize your class.
You can inherit more functions.
Yeah, I mean, if you write a fish function, specialize it, or a little goldfish.
Yeah, I would maybe emphasize the part that you can extend this stuff. So I would see inheritance as an ease the same thing as above, plus the stuff you add on top of it. In that way, it's also a form of specializing. If you say you also have these generic properties, but in addition you have new stuff.
Now I have a tricky question for you. What is the disadvantage of inheritance?
So compared to what?
That's
I think it's about how to implement polymorphism.
yes, but I
So-
think we will do that. I think there is still one question on class, and then we can go to the difference. Then we ask the tricky question. How are virtual functions implemented? So we were there in that region. You want to pass? No, you cannot.
It's you have a virtual table, and I think the compiler decides which chooses from the table the right function, but I'm not exactly.
Where is the table?
I think the table is everything that's from the base class you write a virtual function, and you can write other classes which are inherited from this class, and I think then that creates the virtual table. But I'm not exactly sure.
Someone wants to complete the answer? So what you said, it's more or less correct. So when you start using virtual function, when you start using virtual function, they have to be virtual from the base class when you want to call them. And as soon as there is a virtual function, the compiler will create a virtual table, and all the derived classes will put the right pointer, the pointer to the right function to be called for its own type in this virtual table. So that in the end you have the object with its method, and also the base class knows which one is the right virtual function to be called. Maybe not the one defined by the base class, but there is there is another declaration of the same function, a derived class, so that's overwritten in the virtual table. And now, yes.
Question. If you implement if you define a virtual function, you have the possibility to set it equal to 0.
Mm-hmm.
What does it mean exactly?
Equal 0 means that it's an the exact name, it's abstract.
Pure
or-
virtual.
It's a pure virtual function. It means a virtual function. So if you put virtual, you have to. If you only put virtual, you have to implement the function. You have to define the function. You have to put what it does. If you put equal 0, you just leave the definition the declaration of the function, and you have, so if you have a class with a pure virtual function equals 0, which are pure virtual function, you cannot create a type with the type with this base class, because it's not fully defined. It's missing this virtual function. And the equals 0, it's mandatory for all the derived class, saying you are a derived class of me, you have to define this virtual function, or to pass it over to another derived class. Otherwise, if you don't put the equals 0, you have to define it in the base, and the derived class is not, it's not mandatory for the derived class to declare a new virtual function. The one in the base class could be enough. Yes?
One question. What would happen, for example, if you create a base class like shape, and then derive two different classes and define in those two classes this function called, for example, set color or something like that, but it will be the same function definition. Will there be problems because you did not make it virtual in the base class?
Well, what happens if you do that only? We said that with inheritance you can just extend the class, and once you derive, you create basically a completely new class that inherits, but doesn't have any knowledge at all about the siblings. Let's say it doesn't have any knowledge at all about the other classes that are deriving from the same base. So no, it's not a problem.
So why should we even read then the virtual?
The virtual function is if you want to call the function from the base class, but the base class has to execute the function of the derived class.
So you have a pointer or a reference to the base class, and if this does not have a virtual function of that name, then you cannot call that function, even if it might be implemented by some derived class.
That's one thing, yes. And the other, it's also from the base class. If you just want to call, if you want to impose that the derived class have to define this function, but it's really dependent on how you derive. So yeah, the base class has to have at least this function as virtual, otherwise it doesn't exist in the base class. So let's say you have class A, and you have a function foo, which is doing the cout of the function name. And that's my class A. And then I derive I have a class B, which derives from A, and here we have a function name return, I don't know, something. So now if you have, if in your code, now you are in your main function, you have something of type A, and you want to call A dot foo. How can A point out the name, since name doesn't exist? So it's calling a function that doesn't exist. But even if you have, well, let's leave this one. Even if you have B if you declare B, which it's of type capital B, which inherits from A. So there is the function foo because it's coming from A. But foo needs the function name. But it's going to call the function name of its own type, A, which doesn't exist. So what you have to do here is to have you need a virtual string name function, and then here it's up to you if you want to give it a default value of the function. In this case, you just do something here. Return A, or you just do equal 0, and then it's up to the derived classes to actually define the right function. Yes.
I still don't get it. So basically, it's mandatory to implement every virtual function of the base class, right?
It is mandatory to implement every pure virtual function.
So why declare? Okay, thanks.
You might have some default behavior, which is fine, and then you just specialize it. I mean, you extend it only if it's different. Yes.
So I think the problem here is that you don't see why you need the virtual function, right?
Now it's clear. I'm just confused with pure.
Yeah, I mean, if you want to call the polygon and then do something like set polygon, you need to have a virtual there.
Other questions here on virtual function? Yes.
So it's related to the whole function. When you have a base class and you have some set of functions, when you want to derive a new class, the functions has to have different names from the function from the base class, unless they are virtual. No. Can they have the same names as the function from the base class?
They can, but you might get surprising results. So you can override even non-virtual functions. And then if, say, B is inherited from A and you call that function on B, you will get the overwritten version. But if you now store the address of B in a pointer or reference to A, and the thing is non-virtual, you will get the version that's defined in A and not the one defined in B. So the behavior of the object changes depending on how you access it.
So just again to show you a bit what you can use virtual function for. So that's for example a function which gets as an argument an element of type A as a reference. Means that here I can call bar with B, which is because the type of B, it's capital B, which is a derived class of A. Is it clear for everyone? Yes?
But there could also call a function that's only specific to B, or can I only call virtual functions or functions specific to A?
Once you have this status, you can only call function or virtual functions that are declared inside A. You could do a dynamic cast inside here, and then you do a dynamic cast, and you convert basically your type A to type B, and then you can call the function of B. But if you do something like that, usually it's because you want to pass more than one type. You don't want to only have A and B. Maybe you have many different. You have B, C, and D that all derived classes of A. So it's always usually you define your interface in the base class, and then you can call it in such a function. Okay, now another question. What's the difference between doing this kind of generic programming with virtual function that we have just seen and using templates? That's an important question. Any volunteer?
Maybe you should give an example. So,
I just...
sorry. Just write a template.
Yes, yes, yes. So here we can do a bar of A, and it works. We can do bar of B, and it works. Another function, now I'm running out of names.
Yeah, you can just say template class T void bar.
Class. Yeah, let's use the same. Now, you agree that even here I can call bar with the variable A and the variable B, right? So yes. No, that's down. No. Light. Better? But now you don't see here. Oh, now I don't see you. So the question is, what's the difference between them? One is using templates and the other one virtual function. Yes?
The decision of which version is executed, the template is made at compile time, and the virtual function is at runtime.
Yes. Is it clear to everyone? That's important, remember it.
So which one's better? Why? It's faster. So is there any reason to use virtual functions? Why not always use templates?
If you actually don't know which type you're going to get, so if you maybe make a big vector and then you put in different types, and you want to derive, you want to put in different types, so you make a base class which goes into the vector, and then you can fill it with derived class.
Yes, so it's just not always possible to make the decision at compile time, right? I mean, if you depend like on input of the user saying whether he wants to draw a rectangle or a circle, then there's no way to decide at compile time that he will get a circle. And as you said, you can't put different types into one vector or other container. There was some...
So I think when the function is big, I think it's better to do virtual.
So let's say when the function is big and costly, then you just don't care about the cost of the function call, right? And then, yeah. Well, yeah. Still, any conceptual downsides of the runtime polymorphism with virtual functions? Yes.
If you want to make a library itself, then it's not really a good idea to write templates because you have to give your code to your customer and he will not buy you any, give you any money for the library.
That's a downside of compile time polymorphism. Well, yeah, you could instantiate the stuff for the types that you know you support and compile these, but then it won't work for other types. Yes. But downsides of the virtual functions, apart from speed considerations? That's a tricky question, I guess. So speed considerations apart, would you recommend someone to write like the standard library using runtime polymorphism? So let's say a vector gets a pointer or reference to some vector insertable type, and everything that can be put into a vector needs to be derived from vector insertable type. Or a sort function that needs to be derived, so all the types that could be sorted need to be derived from a sortable type. Yeah.
You make it a little bit less generic because you cannot put in anything. You always have to derive from the base class. So, I mean, else I could just write my own class and not take over the private variables from the base class. Just do it another way. If I use templates, but if I use virtual functions, I always have to derive the base class.
Right, so that generic programming with templates gives you also more flexibility, because you can say, okay, I require these concepts to be fulfilled, and then my function will work, even if I get a type from a user that doesn't know about my base classes and has written his types without considering mine, right? So that might not be the biggest concern if you write your user code, but for something like the standard library, that's of course a big concern.
Should we move on?
I guess so.
So next, what are exceptions? Many students failed on this question during the exam, I remember. So now, this column. Anyone there? What are exceptions? Up there? You? Exceptions. Yeah, some of you. So have you used exceptions? Were they already in the class?
I hope so. Yeah.
Okay, I mean, I didn't see the last slide, so.
No, they were there.
So no one, no, not you. Yeah, you can.
Concept to deal with problems during runtime, and you can throw exception at the user to just say something like, yeah, there was an error in this and this, correct this, or you can just throw an exception to abort the program because it wasn't able to execute the program because he could have used the preconditions or something like that.
Yes. So more correctly, it's a way to interrupt the usual control flow of the execution of the program until some parts of the code will eventually catch the exception. So yes, it's a good way when you have to deal with errors, with broken preconditions, even if there you could use asserts instead of exceptions. And yes, do you know how to use them? Have you tried to write an exception class? Never. Have you tried to throw an exception in one of your programs? and to catch one. Maybe you can give it a try before the exam. Do you want to clarify the definition? It's fine, huh? Good.
Otherwise, you should ask that you want more explanation.
What's the difference between assert and an exception?
One has to be stated in the preconditions and the other doesn't. I don't know which one. And one you can just
So which one?
assert has to be stated in the precondition. And then, yeah, if it doesn't meet the preconditions, you can delete the function.
Right, okay, but then, so let's say if I have an error and I want to, if that happens, I want to do something else. Can I do that with an assert?
Save something.
Can you catch an assert? An assert?
So if the something else is abort the code now, then you can do it.
You can exit. But if you want to, okay, so if you want to do something more specific, like if this fails, then still continue, but change something, right? Then you should do the exception. If you just want to abort the code, if this condition is satisfied, then you do it.
I think you can do specific stuff with asserts. You can write out stuff you can do, but it's predefined. And the exception
Yes, I mean,
dealing with is that is the user of the library has to deal with it. And the assert, the person that writes the library has to deal with the exception.
so how would you do something else except splitting the code with an assert?
You can just write out the line.
That's not an assert.
That's, yeah, that's an if.
No, you can put an assert and then write out the line.
Are we talking about the same language?
Yeah, maybe that's,
No, you can put a function that checks and then you just return false. And you could do some stuff with assert. You just pass a function which does the check itself if it's true or false. Then in case it's false, it's doing cout.
but that's still just returns a boolean.
Yes, in the end you return a boolean. And
That
you,
boolean is false, it will exit no matter what.
yes.
I mean, the point of the assert is that whenever it fails, meaning it gets a false value, it aborts the program, right?
And with an exception that if something happens, you can still continue running, yeah, but change some parameters, set some parameters, call some other routines than you would have done with the normal execution.
So that's the assert that you have in the standard C library. Some programming frameworks give you something also called assert that might do all kinds of stuff, but that's not the one in the standard.
Yes, good.
Yes, there's one more important point, which is related to debug and release builds. So all these asserts are disabled if you define the macro ndebug, right? Which is typically done for high-performing release builds, which of course means that you should not use assert to check if the user tries to get your program to override the hard drive, because you would disable that check then in the released code. So you should use the assert to check for internal inconsistencies, but not to check input that's provided from outside of your code. That you should deal with in the normal way or with exceptions.
Good. Let's move to the next section. Almost the last one. Data structures and algorithms. What's the complexity?
does the execution time change?
Fine.
Like, I mean, does it scale linearly if I put n data points? If the execution time increases n times, then it is O(n).
Yes.
If it increases O(n) squared times.
Correct. The only detail is that when we speak about the complexity with the capital O, that's the worst case complexity. So it's, for example, if you have to search, you might be lucky and the element you search is the first one. So this might be complexity 1. But the complexity we write with the capital O, it's usually it's the complexity for the worst case. Which data structure and STL container do you know? Any idea when you prefer one respect to the other? I know the vector. Who knows something else? Since you have it during the exam, you can check on the CPP reference website if you want. There is a list of them. A list, it's a state container. Another one, for example, a set. What's the difference between a set and a list?
List is one-dimensional, so and set is like a tree, so like a binary tree.
When do you use one and when do you use the other one?
We use list when we want to erase and insert linear time, and but the search and the search is in constant time because the insert and erase, and in the tree we can search and erase in logarithmic time.
Is it always linear, the remove insert in the list? It's always constant. What if I tell you remove the 5th element?
So yeah, I have to go to the 5th element, but if I'm there, then...
If you're there, yes.
So if I want to remove the 5th element, I have to find the 5th element and then remove. So the find is linear,
Yes.
and then remove is constant.
What about the vector?
The vector, to find the element is
How is it called the vector usually? Random access, or?
yeah, so it's constant. But if we want to remove an element, then we have to move the whole bracket part. So it's linear time.
And to find an element, what's the complexity in a vector?
Sorted logarithmic.
But in a vector, I mean, it's just essentially a C array with some nice things. Right? So if it's sorted or if it's not sorted, it doesn't matter.
But you know.
You know, yeah. Make let's say some kind of search algorithm to use it.
It's already in a standard library.
It's already in the stand.
But the vector itself?
You can use lower bound with the vector, but you have to have a sorted. But there is no precondition check in the lower bound. So if you give it as an input something which is not sorted, you get crap. Okay, is this more or less clear? I think we also had an exercise for this. Huh? What's an iterator? Who can give me a definition of iterator without using the word iterate? Let's be a bit more challenging. Someone here. You are 3. Pick who wants to give me an answer. Yes?
Your pointer which shows the elements of the container and can be used to go through the container.
So how did you start saying that it's a pointer? In the special case of the vector, it's a pointer.
Sometimes.
Sometimes. let's say a pointer, it's an iterator. I mean, a pointer to an array, it's an iterator. It can be seen as, I mean, fulfill the concept of an iterator. But an iterator can also be something else. Just have to fulfill the concept of the, how many concepts for the iterators are there? The forward iterator, bidirectional, random access iterator as well. Backwards. There is also the one where you can write and where you cannot write, or?
Yes, input, output.
All right. So there are a few concepts for the iterator, but basically it's an object you can use to go through your container. For example, if you have a state map, there is no really well-defined way to go from one element to the other. That's what you do with the iterator. You can do, you can write an algorithm which just doubles every entry in a container. And it's easy to write a for loop if you just have a vector. But if you have a list, you can no longer use the random access element. So you have to do something else, and that's the iterators. So it's an object you can use to go through your container. And it, oh, I'm running out of battery. So we have to be fast. And I cannot even click on this stupid stuff. So let's be fast, it's only 2 slides left.
Mm-hmm.
How do you generate random numbers?
Oh, yeah.
Give me a random number. Give me a another number. Yes, do you know any library you can use to generate random numbers? So if we ask you in the exam to generate a sequence of random numbers, you know how to do that. Good. What if you don't have C++11? Yes? Yes. Without internet connection, right? Or what if we give you the equation of a pseudo-random number generator? Do you know one definition? I'm pretty sure it's not going to, well, I cannot say anything about XM because I still don't know anything about XM. But do you know how to generate a linear congruential random number? That's easy. Or? Like? Okay. Is it a good random number?
Yeah, the problem is you really need to specificate in the C for it to actually be not that bad. It's not good, but if you take the wrong A, B, and C, it's really bad.
What if you take C equals 2?
You could use that to make a nice kit.
Well, I think you have some correlation there as well, anyway. Like even not even. But if you just output numbers, is there a way I can tell you if this is random or not? As a user, if I just see a sequence of numbers, there is almost basically no way to tell if it's random or not, because the sequence might change at some point. Because I just ask for numbers, I don't see how you generate them. Even a random number generator that just prints 42, in principle, it's a random number generator, if you fulfill the interface and the concepts. Just that at some point you realize it's a useless random number generator. So do you know one application where random numbers are useful? Which is not the Penna model. Yes? What's Monte Carlo? Online casinos? That's also an application, huh? Okay. Have you used random numbers for something? Was there an exercise
Yeah.
on pi? Perfect. So you know how to compute pi with random numbers. Good. But no exercise on testing, right? Then let's skip the question. Optimization. How many sections do we still have? I mean, the oral exam usually it's just 20 minutes, so that's really a long exam. What's a software library? How can you generate it, and what are the advantages of having a library? I think we discussed it already a bit. So you can use a build system to generate a library, or if you want to write a make file, just be sure you can write it. Should you optimize your program? I think you already got a reply to this question in the previous lectures. So, what's the good answer? No. But what if you want to do at least something? Do you know some small tricks? There is one trick that we practice a bit, and you should really, in case there is such a question, you should really mention that. Yes? Data locality, yes. That's important, and it's something that the compiler cannot optimize for you. If you pick a wrong data structure where the data you access is not contiguous, is not local, then you really lose a lot. And that's something where you can easily gain a lot if you just keep all your data local. And another trick that I just mentioned explaining, it's picking the right container. Just looking at what you have to do, if you have to sort, to insert, to remove, or random access, you might pick one or another container. What is inlining? Yes?
It means you don't actually need a function call, so when you write f(x), it actually prints the whole function into the code where it is. So if you call f(x) and f is, for example, x times x, then it will just print. It will be the same as if you had printed x times x right there. So you don't need a function call.
Yes, but it's something that if you write inline always happens.
No,
The compiler can still decide. And when should it be used? Always? Is it always if I have a big function? Okay, given that the compiler can do whatever he likes, but assuming it's doing what I want, if I have a huge function and I put it as inline inside another big function, is it a good idea or not? Yes?
It should only be used for small functions, because if you use big functions, the kind of a code cache in the processor will be filled up, and you will, with the entire code of the function, and then you may be slower than
Yes, you make your program much larger, and then you have problems with you get problems of speed with instruction cache. Given that that's all theory about old computers, so I think that with, let's say nowadays, I just trust the compiler, which is doing the right stuff. But
why should it be slower? Because if we call function, we have to read the instruction that are written there. So if we inline it in our source, in our code, then I read it directly. But if I don't inline it, I have a call function, then I have to look at it. I have to read the function, and then come back to mine. So the operation I have to do, the reading operation are always the same. No?
If you only call it once, yes, but as soon as you call it twice or several times, then the code size will blow up with the number of times you call it. And so let's say you write f of x times f of x, then you will write there in your code, have twice the code executed right after another. And so you will consume twice as much space in the instruction cache.
So it's a memory problem of the. Well, I don't see the problem because I have to go in this function twice. No?
So the point is that the CPU has to load the code, just like data,
And
and then it has to decode it, make sense of the machine language. And if you do now, if you basically copy and paste the code, then it has to do that for all that code over and over again. Otherwise, it just loads it once, decodes it once, keeps it in the most internal instruction data cache or in the register, and will just jump again to the already decoded instructions and run them again.
Question to your example with f of x times f of x. When you write const on f of x, and the compiler knows that this will not change the value of x, will he evaluate it twice or just once?
So, in general, the compiler never knows what the function is doing if it cannot analyze it at the same time. So it might write to some global variables or something, have some side effects, and therefore it can never optimize out the function call. In the new standard, there's a const expression stuff saying it's always the same, but in general, function calls are always a limit for compiler optimization.
Okay, there is not much time left in the end. I believe this was really a short lecture, but it's taken some time. What is assembler? We already discussed it a bit. What are expression templates? Is there something else here? Okay. Expression templates. It was in the last lectures, we had it in the exercises. Who can explain me one example where it's useful? Yes?
Sum up short array.
Why?
Because we don't have to make the dot product. We don't have to make a normal iteration over all the entries of our array. But with expression templates, the compiler, if we program it right, the compiler sees that in the end, what it gets is the unrolled loop, and so it can cancel the rest what we created before. So this is of objects, template objects, and we have the unrolled loop at the end in our code.
So for tiny vectors, you can unroll loops, like if you have a dot product. Another examples is when you have, even for big vectors, if you just want to sum 5 vectors together, and you have your vector type, and you define the operator plus to always loop through all the elements and create a new temporary vector. If you have to repeat this operation 10 times, you just waste the loop, since it's a loop from I to the size of the vector that can be large, and you do that many more times, where one could be enough. And I think there was also, I'm pretty sure there was in the lecture an example where you just do the sum of many vectors with only one loop, or?
So I think the example you're referring to, that's doing the loop unrolling with a template meta function, is not exactly an expression template. It's just using meta functions for the unrolling at compile time. So the expression templates were really that part concerned about optimizing away the temporary objects that you would generate for an expression like A plus B plus C, if A, B, C are vectors or matrices or something like that. And that then also allows you to do the result with one single loop instead of rerunning the loop over and over again. But an important point is really the getting rid of the temporary objects that you would get by just usual operator overloading.
Let's move on. Libraries, and that's the last one.
Do we have to discuss that?
Do you know how to include Fortran and C libraries in C++ program? What? Louder? Extern C.
Or include a wrapper that has been written for us. That's much easier.
Do you know what is the extern C actually doing? Yes? Yes. Good. Okay. Do you have any other questions? Anything we didn't touch in this long list of questions? Good. Otherwise, I think we are done for today's lecture. Next week, it's very likely that we have a lecture, a usual lecture, both on Wednesday and Thursday. So on Wednesday, just again to remember you, it's again in the HPT building, like we did all the exercises except the last week. So this week.
Yesterday.
So it's, let's say it's the usual place, and well, maybe we will write a mail in case there is a usual lecture or not. But it's very likely you will get Professor Troyer on Wednesday and Thursday as well.